Hi, now, I was really surprised with this linear programming question, and everybody did it so badly. Well, not everybody, but most people did quite badly on it. That was because we couldn't form those equations at the start. Okay, so that's what we need practicing with. We need to practice forming those initial equations, because without those, you're not going to get anywhere, are you? Right, so let's read the question. Robin manages a bakery, and each day the bakery bakes 900 rolls, 600 tea cakes, and 450 croissants. The bakery sells two types of bakery box which contains rolls, tea cakes and croissants as shown below, standard and luxury. Right, so the first thing you need to do is declare your variables for any linear programming question. So let's say that X is standard and that Y is luxury. So we'd need to write that down to declare our variables. We'd have to say, right, we'll let X equal the number of standard boxes. And we have to include that word number. I know I've written the sign, but you'd have to write number of. And Y equals the number of luxury boxes. Okay, so that's where you're declaring your variables. Right, keep reading. Robin formulates a linear programming problem to find the maximum profit the bakery can make. So the maximum profit, okay, what we're trying to optimize is we want the maximum profit, so we want to maximize P. Now P is equal to the number of standard boxes you sell and the number of luxury boxes you sell. But hang on, we're talking about profit here. How much do you make for a standard box? You make £2.50, right. And how much do you make for a luxury box? £2. Well, this is profit, right. So our profit is 2.5 times X, or £2.50 times X, plus 2 pounds times Y. So this is in pounds. Our profit here is in pounds. Okay. All right, now let's look at the constraints that are going to be on this problem then. So they make 900 rolls. So in a standard box, we've got 12 rolls, and in a luxury box, we've got 6 rolls. So the number of standard boxes times 12 plus the number of luxury boxes times 6 has got to be less than or equal to 900, because that's the maximum number of rolls we can have. And we need 12 rolls for a standard, 6 rolls for a luxury. Okay, then we do the same with the tea cakes. So 6x plus 6y has got to be less than 600, because that's the maximum number of tea cakes we're making. And then lastly, we've got 3x for our croissants plus 9y has got to be less than or equal to, what we're doing here, 450 croissants. So we've now formulated a complete linear programming problem. Now obviously we can simplify these. I mean, this one's got a common factor of 6. This has got, has it? Can you do 900 divided by 6? I'll worry about that in a minute. This one common factor of 6, this one common factor of 3. Right. So basically, if you look ahead in the question, use the graph to find the maximum profit the bakery can make from selling boxes, state an assumption you've made. Right, okay, and here we're just defining our variables here. So for part 1 here, you get the marks for defining the variable and saying how that relates to this graph. Okay, so now we've already formulated the problem, so let's have a look at this graph. What's the equation of this line? Well, here we can see it's got a y-intercept of 150 there. Okay. And let's have a look at the gradient of this line. What do we think the gradient of this line is? So let's pick a point that we can see clearly. Not very clear, this graph, at all, really. Let's pick a point we know. Come on, let's find a point we know. I mean, we could take the whole graph, couldn't we? Could say, right, it's 150 up, and I think that's supposed to be 75 across the bottom. Yeah, it's going to be 75, isn't it? So the gradient of that graph is 150 over 75, and it's negative. So the gradient of that graph is -2. So the equation of that line is that y is equal to -2x. Remember, just in your form, y equals mx plus c. Y equals -2x plus 150. Right. Okay. So where have we seen something like that before? Well, let's have a look at this top equation here. Let's divide everything there by 6. That would give us 2x plus y equals 150. Oh, sorry, is less than or equal to 150. Okay, now if we rearrange that, then y has got to be less than or equal to minus 2x plus 150. Ooh, which is the equation of this line. So this line here is related to the number of rolls. Remember, this 12x plus 6y came from the number of rolls we're making up here. So this line is about the number of rolls, and we want where it's less than or equal to that. So we want underneath the line. So remember, we shade out the region we don't want. Okay, so you'd shade out that side of the line there. Okay, so it's basically saying we've drawn the first line for you. So because this is a linear programming problem, you then continue on and do the rest of your lines. So we've got 6x plus 6y is less than or equal to 600. Well, that's the same as x plus y is less than or equal to 100. Rearrange that. We've got a gradient of -1 and a y-intercept of 100. So we're going to draw that line in there. That'll go to 100 there. So we want to draw our line there. Ah, now you do this with a ruler. I'm doing it with a really dodgy pen. Okay, so that's that line. And then the 3x plus 9y is less than or equal to 150. Rearrange that. Let's divide it by 3 first. Okay, so then we get y is less than or equal to minus x plus 150 all over 3. Whee! So that's a gradient of minus a third and a y-intercept of 150. So minus a third would take you to 50 there, wouldn't it? So 150 divided by 50. No, it wouldn't. It wouldn't. I'm talking rubbish. A gradient of minus a third. Oh, it's going to be way over there somewhere. So really, we want to go from, if that was 50 and that was 150, that would give us a change in y of 50 and a change in x of 150. So that would give us a third. So I'm a negative, so negative third. So roughly, this is the region that we're looking at now. This region that's left unshaded here. Okay, so from there, you're then going to look at your maximum profit within there. And remember, we're trying to maximise 2.5x plus 2y. So we're trying to maximise the profit. Where's my pen gone? There it is. We're maximising the profit of 2.5x plus 2y. So we'd need to draw that line on there. So if we went like that and like that, and no, 25, we want about that like that. So it's parallel to this line here. So we want to be parallel to this line here. Now, obviously, testing the vertices is what we're supposed to do here. Okay, now we can clearly see, I think, that there's a vertex at 60 here. Now, obviously, your graph's going to be a lot more accurate than mine. You can test each of the vertices, though. That's what you should do. You get a mark for doing that. So here, x is 0 and y is 50. So you could test that, and you could test that and that. So I think I'd be tempted to test this one. So when x is 60, if we identify that line, it was the third line we drew. You can substitute it into this line here. And that gives you that y is... well, minus 60 plus 150 is 90 over 3, so y will be 30. And I think that is actually your answer. When x is 60, y is 30. So you can then substitute that into there, and that will give you the maximum profit you're going to make. So 60 times 2.5 is 150, plus 2y, so 100. So the maximum profit you're going to make is £210. Sorted. Oh, and the very last bit of that question, it is broken down slightly, but there's 9 marks for doing all that. State an assumption that you've made. Well, an assumption basically is that you can sell all the boxes you make and that there's going to be nothing left over. But it is quite lenient with that. Right, hopefully that helps.